here let's look at some concrete examples. And this domain is particularly important given that, as we all know, machine learning models, they are really data hungry. They are trained through a huge volume of data, and a lot of this data is really sensitive, and hence the user's data privacy protection is really important as we train and deploy these machine learning systems. So here is a concrete example illustrating why it's important for us to pay attention to protecting users' data privacy as we train machine learning models. So here's a recent work that we did in collaboration with researchers from Google. And here the key question that we set out to explore is, do neural networks remember training data? And if yes, can attackers actually exploit this to extract the secrets in the training data from just simply querying the learned models? So in particular, in this case, we look at the task of training language models. So the task of training language models is by taking a corpus of text, for example, an email data set, then try to learn a prediction model where it tries to predict, when given a sequence of words or characters, it will try to predict the next character or word. So in particular, in this case, we studied the task of training a language model over a data set called the annual email data set, which naturally contained actual users' credit card and social security numbers. Our work showed that attackers, by devising new attacks from just simply querying the language model without actually knowing the details of the language model, including the architecture and the parameters, it can actually extract the original credit card and social security numbers that were embedded in the original training data sets. And these are examples illustrating that why it's important to pay attention to users' data privacy, even as we train machine learning models. Luckily, in this case, we have a solution. And the solution is that instead of just training vanilla machine learning model, instead, if we train a differentially private language model, we can still provide fairly high utility, and at the same time, we can significantly enhance the privacy protection for users' data privacy. And differential privacy is a formal notion of privacy notion. In particular, we say that a randomized algorithm is differentially private if it satisfies the following property. We consider two neighboring data sets where one data set has one more points than the other data set, for example, Joe's data points. And when we compute the randomized algorithm or function over these two neighboring data sets, when we look at the computation results, the resulting probability distribution of the computation outputs, the two distributions are very close. And at high level, essentially, what this is showing is that by just looking at the computation outputs, the attacker won't be able to distinguish whether Joe's data has been included in the original computation or not, and hence help protect Joe's individual data privacy. And also, our recent work has also developed automatic methods and new type systems to be able to statically enforce and verify that a machine learning algorithm is differentially private and provides provable bounds on its on the privacy guarantees. And the work has won the Distinguished Paper Awards at Oasis, which is the top programming language conference. So what I have talked about in terms of protecting user privacy, in particular as we train machine learning models, That's just one example. And again, it's just the tip of the iceberg. As we all know, data is critical to the modern economy. But however, a lot of this data is really sensitive. And handling the sensitive data has posed unprecedented challenges for both individual users as well as businesses. Individual users have lost control over how their data is used. And also, a lot of user data has been sold without users' knowledge and consent under the umbrella that the dataset has been anonymized, where certain personal identifier has been removed. But however, a lot of work has shown that anonymization often is insufficient in protecting users' privacy, like the recent New York Times article that has shown that they were able to track the location of a Secret Service agent with the President Trump from an anonymized data set collected from location data from mobile phones. And also, users are not getting sufficient benefits from their data. And also, on the other hand, businesses continue to suffer as well. For example, they continue to suffer from really large-scale data breaches. And also, it's becoming increasingly more cumbersome and expensive for businesses to comply with the regulations such as CCPA and GDPR. And even more importantly, it continues to be really difficult for businesses to utilize data due to data silos and privacy concerns. And also, as we develop new technologies that can unlock utility, it may also oftentimes come at the cost of privacy. And hence, we cannot continue with the current status quo. The current status quo hinders societal progress and undermines human values and fundamental rights. And hence, we have an urgent need for a framework for building a responsible data economy. Building a framework for a responsible data economy is a complex problem for a number of reasons. One, there's natural tension between utility and privacy. And also, data is non-rival, meaning that data is unlike a physical object, where for a physical object, if A holds an apple, the same apple cannot be held by B at the same time, or B. Whereas data, the same piece of data can be made many copies, and different entities can all hold the same data at the same time. And thus, we cannot simply copy the concepts and methods in the analog world to help address problems in the digital world. And thus, to build a framework for a responsible data economy, it requires a combination of technical and non-technical solutions. And in particular, it needs to have at least 3 components: the technical aspect, the legal framework, and incentive models. For technical solutions, we need to develop new technologies that addresses the insufficiencies from traditional solutions. In particular, we need to develop new technologies that not only protect data at rest or in transit, as the existing data encryption does, we also need to protect data in use and in compute. And also, we need to enable controlled use of data without having to copying the raw data, which will cause the data owners to lose control of their data. And furthermore, we need to be able to protect the computation output from leaking sensitive information about the inputs, as we have seen that, for example, anonymizing data often does not provide sufficient protection to privacy. And luckily, we have seen a really exciting and rapid advancements in different component technologies to enable responsible data use. This includes secure computing to try to help protect the computation process from leaking sensitive information, utilizing techniques and solutions such as secure hardware, as well as crypto-based methods such as secure multi-party computation, homomorphic encryption, and so on. And also differential privacy for protecting the computation outputs from leaking sensitive information about individuals. And federated learning helps the data owners to keep data on their local devices and machines and enable different entities to together train a machine learning model in a distributed manner. And this can also help further protect users' data privacy. And with distributed ledger, it can help provide an immutable log to ensure the user's rights to data and also how users policy of how their data can be used, and also to provide an immutable log of the usage of the data. At Oasis Labs, we are also working in pushing forward these different component technologies and also weaving together these different component technologies to enable a secure distributed computing fabric that can serve as a platform for a responsible data economy to help address many of the challenges that I mentioned earlier. As a concrete use case to illustrate the capability and the power of these component technologies and the platform for a responsible data economy, here let me give you just one example of a use case in genomics that we have been working on. In direct-to-consumer genomics, companies essentially collect users' genomic data and help provide genomic analysis results to users. But however, recently we have seen layoffs in these direct-to-consumer genomic companies, in particular citing privacy concerns of consumers as a main reason for a slowdown in consumer adoption. So in collaboration and in partnership with another genomic company, we are in the process of launching a product and service. When this is launched, this will be the first time where users can become owners of their genomic data in the sense that they can maintain control over their genomic data and how their genomic data is used. Their genomic data will be stored in encrypted form, and the users get to specify how they want their genomic data to be used. For example, they may allow a genomic company to provide genomic analysis of their data. But in this case, by utilizing secure computing, the genomic company will not get a raw copy of the user's data in this case, and the genomic company can, if the user allows the genomic company to run the analysis, the genomic company can run the analysis in the secure execution environments to provide the computation results to the user, but the genomic company will actually not be able to get a raw copy of the user's data in this case. And hence, users can maintain control of their data and still be able to utilize their data in a privacy-preserving way and in a controlled manner. Besides technical advancements, we also need more effective regulation as well for responsible data use. And there are many challenges in this domain. For example, what are data rights? Who controls data rights? Individual property rights are a cornerstone of modern economy and has helped establish modern economics and fueled centuries of significant growth. However, today we lack an adequate framework for data rights. Establishing data rights will allow individuals to derive value from their data and propel economic growth and unlock new value. And we need to explore a diverse set of concepts and frameworks. And again, I strongly believe that security and privacy will be one of the biggest challenges in deploying AI. And building a responsible data economy is critical. And this requires community efforts. Let's tackle the big challenges together.